Good morning, everyone. Today, in this session, we are going to continue the last concept, that is classification. In the last class, we discussed what is classification, what comes under classification problems, and the different types of classification problems like binary, multi-class, multi-label, and imbalanced classification. The next concept is about the probability-based approach. You are already aware of this probability. So, what is this probability? And how this machine learning classification problems are implemented with the probability based approach. So if we just let us give an introduction to this probability. Probability simply talks about how likely an event is going to occur. And its value always lies between 0 and 1. Yes or no? Yes, probabilities, if we say simply, we can say that whether a particular event is likely to occur or not, and we know that it all value always rise between 0 and 1. Let us consider one example. We have two bags named A and B, and each containing 10 red balls and 10 black balls in each bag. So if you randomly pick up the ball from any bag and without looking into bag, we surely don't know that which ball we are going to pick up. So in such situations, we need the probability where we are going to find how likely we are going to pick up either a red ball or black ball. And this probability is represented by P of x, where the P stands for probability, where the event x is to occur. Now, the probability of red ball is given by probability of red ball is equal to probability of bag A and into probability of red ball given bag. So when we have this representation, we can call it as probability of red ball given bag A plus probability of bag B into probability of red ball given bag. Now, with the help of these equations, we are going to find out the probability of the red ball. And here we use the concept of conditional probability. This indicates a conditional probability, which finds the probability when we are provided with some condition. So this, when we see this probability of bag A is equal to 1 by 2. Why? Because we have two bags out of which we have to select a bag A. So it will be only one we are going to select. That's why it is 1 by 2. Similarly, as already I told you, probability of red ball given bag A, we are going to read it as probability of drawing a red ball given the bag A. So here the word given specifies the condition which is bag A in this case. Okay. So it is 10 red balls out of 20 balls. That is 10 by 20. So probability of red ball is given by the probability of A is 1 by 2 and probability of red ball given bag A is 10 by 20. Similarly, the probability of bag B is 1 by 2 and probability of red ball given bag B is also 10 by 20. So, which is equal to 1 by 2. So, the probability of the ball which we are going to pick, the red one, is 1 by 2. Now, we know you are already familiar with this conditional probability, that is probability of A given B is equal to probability of A and B. A and A intersection B is read as probability of A and B, and then it is given as probability of B. So here we are finding the probability of for an event A to occur that given that B has already occurred. And this the numerator of the right hand side of this equation is probability of both events to occur. And it is divided by the probability for an event B to occur. So this is what the conditional probability. And there is one famous mathematician called as Thomas Bayes. One theorem is there, that is Bayes theorem, very popular algorithm in machine learning. Bayes theorem. It is named after this particular famous mathematician Thomas Bayes. Okay. Here, what we are going to say, how we are going to find out the probability when one given a hypothesis with evidence. Let us see that. So, in this Bayes theorem, what we require is the probability. Already we discussed the conditional probability, and from these two things, we are going to find out the Bayes theorem. Let me introduce one more time. The probability, it's nothing but the measure of likelihood that an event will occur, and it is quantified between 0 and 1. 0 indicates impossibility, and 1 indicates certainty. And we can take a simple example. It's very famous example for probability. Simply, if you toss a coin, the probability of getting heads or tails is equal to the 50%. Yes, that is 1 by 2. And probability of an event is equal to number of ways it can happen by the total number of outcomes. Okay. So this is what the probability. And coming to the Bayes theorem, it is very, very important. Bayes theorem, what it states is, given a hypothesis H and an evidence E, we have a hypothesis and we also have a evidence. Bayes theorem states that the relation between the probability of the hypothesis before getting the evidence and the probability of the hypothesis after getting the evidence. So before getting the evidence is denoted as probability of H, and the probability of the hypothesis after getting the evidence is given as probability H of H given evidence, is given by the formula probability of hypothesis given evidence is equal to probability of evidence given hypothesis into probability of hypothesis divided by the probability of evidence. So this is the Bayes theorem. What is the formula for Bayes theorem is this one. Okay. And the conditional probability, we already know that A given B is the probability that event A occurs provided that B has already occurred. This is the conditional probability we already discussed. And in probability of theory and statistics, Bayes theorem describes the probability of an event based on the conditions that might be related to an event. That is, probability of A given B is equal to probability of B given A into probability of A divided by probability of A. It is similar to the same this hypothesis and evidence. So Bayes theorem can also be stated like this. Now, when we see this Bayes theorem, the probability of A given B equal to probability of B given A into probability of A divided by probability of B. This is called as the posterior probability and this is called as the likelihood to occur and this is prior probability and this is the given evidence. So equivalently, this Bayes theorem can be written as posterior equal to likelihood into prior divided by evidence. This is one more way to represent the Bayes theorem. So here, the same Bayes theorem. So probability of A given B is the conditional probability of event A occurring given that B is true. So B is already given, A is to occur. And the probability of B given A is the again the same conditional probability of event B occurring given that A is true. Okay, already A is there, we have to find out B. And here already B is there, we have to find out A. And coming to the probability of A and probability of B, P of A and P of B are the probabilities of A and B occurring independently of one another. Independently, this we have to find out probability of A and the probability of B occurring. So let us see some examples to make clear how we are going to find out the probability using the Bayes theorem. Okay. See here, there is one problem statement here. Just read this problem statement. There is a cricket match and in recent years, as per the previous data, it has rained only 5 days each year. Okay. Unfortunately, the meteorologist has predicted the rain for tomorrow. So when it rains, meteorologist correctly forecasts that 90% of the time what he predicted is correct. But when it does not rain, he incorrectly forecast rain 10% of the time. So what is the probability that it will rain on of the match day? So tomorrow there is a match and in a year only 5 days it is raining and the meteorologist predicted that rain for tomorrow and when its prediction is 90% of the time it's correct but 10% it is wrong. So now the question is what is the probability that it will rain tomorrow? So here we know that there is a sample space. Okay. So is defined by two mutually exclusive events. Okay. That two events are, one event is it rains. Another one is it does not rain. Okay. Two questions here. One is it rains. It does not rain. These are the two mutually exclusive events. And additionally, a third event occurs. That is the meteorologist predicts the rain. Okay. So these are the three events. So one is event, let us name it as A1. It rains on the match day. It rains on the match day. And event A2 is it does not rain on the match day. Okay? And there is a third event, okay, that is meteorologist predicts the rains. Predicts rain. Okay? Now we have to find out in terms of probability. So when you take in terms of probabilities, we have to find out this. So what is the probability of A1 here? What they are saying? In recent, it has rained only 5 days each year. Okay, so total we have 365 days. In that, it is going to rain only for 5 days. So what is the probability? That is 0.0136. So when you calculate 5 by 365, you get. So it does not rain on the rain day. That is probability of A2. That is when you remove this 5, the other rains, other days it won't rain. That is 360 divided by 365. So what is the probability that no rain for 360 days in a year is 0.986. Okay. Now, the question is, what is the probability of B given A1? Okay. So, instead of here A3, let me make it as B. B is meteorologist does not, meteorologist predicts rain. So, uh, the next question is, what is the probability of B given A1 we have to find out? What is the probability of B given A? So, what is the question here? When it rains, the meteorologist correctly forecast rain 90% of the time. So, probability of B given A1 equal to 0.9. Why? Because 90% of the time, meteorologist predicts that rain is going to occur. And what is the probability of given A2? Does not rain. What is his prediction? 10%. That is, it is 0.1. Yes. So I hope you clear with all these terminologies. Probability of A1, A2, probability of B given A1 and probability of B given A2. Now, we want to know the probability of A1 given B. What is the question? What is the probability that it will rain on the match day? Okay. So, meteorology predicts rain and on the match day whether it rains or not. Okay. So, this we have to find out. Probability of A1 given B. So what is the formula according to the Bayes theorem? Now we have two mutually exclusive events. So we can write it as probability of A1 into probability of B given A1. Why? Because you can remember this Bayes theorem. Probability of A given B equal to probability of B given A. Okay. Divided by probability of A1 into probability of B given A1 plus we have also another mutually exclusive event, that is it does not rain of the match day. We have to calculate that also. So it is probability of A2 into probability of B given A2. Okay. So place substitute all these values. We already calculated all these values. So what is the probability of A1? It is 0.0136. So 136 into probability of B given A1, that is 0.9 divided by same 0.0136 into 0.9 plus what is the probability of A2? It is 0.986 into probability of B given A2, it is 0.1. So when you calculate, we get that 0.111. That is, the prediction is that it will rain. The chances is 0.1% chances are there that maybe it may rain on the match day. In this way, we are going to find out the probabilities using the Bayes theorem. So when a question comes this probability, so based on the Bayes theorem, we have to find out the probabilities. Okay. That explanation, I have made this PPT very clearly. I have made the solutions. Just pause for a second and make a note of these all answers. Okay. So the probability of A1 given B equal to 0.1. Let us see One more example. Again, this is an again illustration of this Bayes theorem. There are three boxes labeled A, B, and C. Box A contains two red and three black balls. Box B contains three red and one black ball. And box C contains one red ball and four black balls. So the three boxes are identical and have an equal probability of getting picked. Consider that a red ball is chosen. Then what is the probability that this red ball was picked out of box A? Okay. Hope you understood the question. These three boxes are identical and then have an equal probability of getting picked. And we are considering that a red ball is chosen. Okay. Then what is the probability that this red ball was picked out of box A? Let us see this. So let an E denote the event that the red ball is chosen. E is the red ball is chosen. And ABC denotes the respective box is picked. And here we have to calculate the conditional probability that A given E. Okay. That the red ball is chosen given that it is picked out from the box E. Okay. So what I am saying this E denote the event that a red ball is chosen from ABC. This event is from ABC. But the question is what is the probability that this red ball was picked out of box A? So we have to find out the probability of A given evidence E. Okay. So and we have prior probabilities like probability of A or probability of B and probability of C is 1 by 3. Why? Because since all boxes have equal probability of getting picked. Yes or no? Here they have given condition that equal probability of getting picked. We have three balls. So each we have probability that it is equal to 1 by 3. Okay? Now we have to find out, once we are finding probability of A given B, we also have to find out probability of E given A. Okay? That is number of red balls in box A divided by total number of balls in box A. Total number of balls in box A. Okay. So, number of red balls in box A divided by the total number of balls in box A. So, what it is? So, number of red balls, how many we have? 2. And total number of balls is 5. So, when you see 2 plus 3, 3. Okay. 3 plus 1 or 1 plus 4, it is total number of balls in box A is, 2 plus 3, it is 5. So, it is 2 by 5. Similarly, we have to find out probability of E given B. So, what is this one? It is 3 by 4. Why? Because red balls are 3, total is 4. Similarly, we have to find out probability of E given C. So, that is equal to red ball how many? 1. And total number of balls is 1 by 5. Okay. Now, we have to find out the evidence E. That is probability of E. It is given as probability of E given A into probability of A. Similarly, that evidence is, we have to find out that evidence is for total A, B and C. So, similarly, we have to find out that probability of evidence given B into probability of B plus probability of evidence given C into probability of C. Okay. So, what is the probability of evidence given A? We already know that it is 2 by 5. So, 2 by 5 into what is the probability of A? We already we have found out here it is 1 by 3. Okay. Then similarly, what is the probability of E by B? It is 3 by 4 into what is the probability of B? Same 1 by 3. Probability of E given C is 1 by 5 into what is the probability of C? It is 1 by 3. So when you calculate all these things, the probability of E, you will get it as 0.45. Now, what is the question we have to find out? probability of A given E. That is equal to probability of E given A into probability of A divided by probability of as per Bayes theorem. Okay. So what is the probability of E given A is equal to how much it is? It is nothing but 2 by 5. Probability of E given A is 2 by 5 into what is the probability of A? It is 1 by 3 divided by what is the probability of E? A combination of all these, that is 0.45. So what is the probability that this red ball was picked out of box A is equal to 0.296. So when you calculate this, you will get the probability as 0.296. Okay, this is how we are going to find out this probability using the Bayes theorem. I hope you understood this. So a clear explanation of this is being given in this slide. You can cross check it. Okay, this is what the illustration of Bayes theorem and how we are going to find out the probability using Bayes theorem. And Bayes theorem is one of the popular supervised machine learning technique used for the classification problem. Thank you.